We are going to start today's lesson with some review problems. So the first problem says x squared minus 9 equals 0. This can be solved in two different ways. We can factor the equation and say x plus 3 times x minus 3 equals 0. So x will equal to negative 3 or x will equal to 3. The second equation, we can do the diamond method in factoring, negative 5, negative 14. So our two numbers will be negative 7 and positive 2 over x. So we'll have x minus 7 times x plus 2 equals 0. So x will equal to 7 and x will equal to negative 2. The next equation is a perfect square, so I can just say x plus 5 to the second power equals 0. Therefore, x will equal negative 5, and negative 5 is a double root, since I have two factors of x plus 5. On this last problem on the slide, we are going to factor out 4x. So 4x times x minus 2 will give me 0. So the solutions will be x equals 0 and x equals 2. We need to write the equation of the direct variation. First, y varies directly as x if y equals 8 and x equals 20. The equation for direct variation is y equals k times x. If I substitute in 8 for y and 20 for x, then I can divide both sides by 20 and get k equals, the constant of the variation will be 2/5. So the equation will be y equals 2/5 x. If y varies inversely as x, the general equation will be y equals k over x. So I need to substitute in 20 for y and k over 8. So if I multiply both sides by 8, I will get k equals 160. So the equation for this variation will be y equals 160 over x. On this next slide, we need to rationalize the denominator. So I'm going to start with the first one by multiplying by root 2 over root 2, which will give me the square root of 2 over 2 times the square root of 4, which is the square root of 2 over 2 times 2, or 4. On the next problem, I am going to first simplify and get 2 times the square root of 2 over the square root of 7. And now I can multiply by the square root of 7 over the square root of 7. So I will get 2 times the square root of 14 over the square root of 49, which is the same thing as 2 times the square root of 14 over 7. So for the last problem on the slide, we need to multiply by the conjugate, which will be 3 plus root 3 over 3 plus the square root of 3. So when I start simplifying, since I only am multiplying by 1, my numerator will just be simply 3 plus root 3. My denominator will be 9 minus 3. So if I simplify the denominator, it's 3 plus root 3 over 6. On the next problems, the question is asking us to express in terms of I. So since I know that the square root of negative 1 times the square root of 7 gives me the square root of negative 7, and I know that the square root of negative 1 is I, so simply I can write I root 7. On this next problem, I'm going to say the square root of negative 1 times the square root of 4 times the square root of 5. So if I simplify, I will get, first, I am going to simplify the square root of 4, which is 2. Then I am going to simplify the square root of negative 1 to I, and square root of 5. In today's lesson, we are going to solve quadratic equations in the form of ax squared plus bx plus c equals 0. And most of the problems we are going to solve by completing the square. A second degree or quadratic equation in standard form is written as ax squared plus bx plus c equals 0, where a, b, and c are constants and a does not equal 0. There are several other methods to solve quadratic equations, just like in the previous examples we did factoring. We can also take the square root, we can use the quadratic formula, or completing the square. Here are 4 examples to solve. We are going to get started on the first one. The first one is simplest to solve by taking the square root. So first I'm going to subtract 3 from both sides and get 2x squared equals negative 3. Then I will divide both sides by 2. So x squared will equal to negative 3 over 2. Then I take the square root of both sides, and since I have a negative number under the square root, I'm going to end up with an imaginary number. So this will give me plus or minus I root 3 over root 2. And by rationalizing the denominator, we are going to multiply by root 2 over root 2. So the final answer I'm going to write up here will be x equals plus or minus I root 6 over 2. For the second example, the first thing I'll do is I will multiply the two factors, x plus 2x minus 2, together and get x squared minus 4 equals 2 minus x. Then I'm going to move everything to the same side. So I will have x squared plus x minus 6 equals 0. So now I'm going to see if I can factor this using the diamond. So I have 1 and negative 6. So I could have 3 and negative 2 over x. So factored form is x plus 3 times x minus 2 equals 0. And so the two solutions are x equals negative 3 and x equals 2. Example number 3, I am going to factor out an x. So x times 2x plus 7 will equal 0. So the two solutions will be x equals 0 and x equals negative 7 over 2. And on this last one, I will similarly do this one as I did the first one on this slide. I'm going to add 7 to both sides. So I get 5x squared equals 7. Then I'm going to divide by 5 and get x squared equals 7/5. And then I take the square root of both sides, and I will get x equals plus or minus the square root of 7 over the square root of 5. And again, if I want to rationalize the denominator, which I don't have room down here, so I'm going to move it up here in the middle. I'm going to have to multiply by root 5 over root 5. So if I do that, x will equal to plus or minus the square root of 35 over 5 for my final answer for this problem.